Hello, good day once again. So, for our next topic is all about partitioning and formatting. This is one of the critical part of system installation, and usually the system administrators take this job because they are the first ones who will be configuring systems. It might be single user systems or multi-user systems. So depending on the size of a system, you can partition, you can create of partitions. It also depends of the number of users and their needs. You can create different schemes can be selected. Then you may have a single partition, you may have multiple partitions that might be used in your hard drives, in your SSDs, in your M.2s. And the partitioning will also depend on the type of the hardware available or involved. When you talk about partitioning, your disks, your drives, your SSDs are divided into partitions. You can use up to four primary partitions in your drive, in your hard drives. If you will be using SATA, SATA, this can support up to 15 partitions. So in Linux, let's say for example, this is your hard drive, number one. This will be called SDA. Okay, your first hard drive will be called SDA. The first partition will then be called SDA1. First partition of the first hard drive is SDA1. Second partition of the first hard drive is SDA2. SDA2. And then you might get or you might already know, so on, so forth, SDA3, SDA4. So this is your fourth partitions. Okay. Let's say you have another hard drive, second hard drive in your system, and you partition it into four partitions again. So in Linux, this will be called SDB. Okay. Second drive is SDB. Your first drive is SDA. Your second hard drive is SDB. So if you'll partition your second hard drive, the first partition of the second hard drive is SDB1. Second partition of S hard drive number 2 is SDB2. And then so on and so forth. Why do we need to partition? It's said that's for separation. We decide to separate system files from user files. Let's say you want to um, for what? You want to separate the system files like the operating system files from user files. We usually do this in our Windows. Separate C and D, wherein drive C houses all the Windows operating system files, and the drive D is where the documents, the files, the pictures, the videos, audios, or any files of the user are usually placed. So if ever there will be problems in the operating system, then you can just reinstall or reformat drive C only without touching or doing something in the drive D partition. Okay. Sharing. Okay, why sharing? So multiple operating systems may use the file systems. Okay, let's say for C and D, we have that's an example already. We might install Windows on drive C, It could be Linux on drive D, and that is possible. So one hard drive, one SSD, two different operating systems. Windows on C, Linux on D. Then with that, you can mount your home/home in a Windows network. In regards with security, we can impose different quotas. Okay. Let's say for a particular user, for this hard drive, you're only allowed to have 10 gig of file size. Once you reach your limit, you can't access that partition. You can't access that particular directory because it is attached to the partitions. And those concerns with permissions and the settings for each partition. Okay. Linux can do this. Okay. We can do this. It also involves performance. So data which is read often will be accessed rapidly if placed in a partition on a quicker disk. So let's say this is your SDA, okay, which is an SSD. All the operating system files are placed here, and all your data will be placed on another hard drive. Let's say your documents, your files are placed, personal files are placed on another hard drive. So as we all know, SSDs, solid state drives, are faster, can be accessed rapidly than a SATA drive. This is the common partition layout for Linux operating system: the /boot directory, the /swap, and the /home. If you have these two partitions here, swap and that /directory, basically you can run with this a Linux operating system. You can run a Linux operating system with these two partitions only. In Linux, there is a command called driven partition table editor, in which these commands are available for you to partition, to format your disk. Okay. This is the most standard and most flexible um, application in Linux that it's still being used today. If you will type fdisk and then slash uh, the hard drive, okay, what hard drive will you be accessing? You will be given this window, okay, wherein you will be uh, given some commands. Like for example here, if you type D upon typing sudo fdisk, and then it means here the administrator is accessing the first hard drive. So you can, if you type D, you can delete a partition. If you type L, it will display all the known partition types. If you want to create a new partition, you can type N and then add a new partition. So some common commands: fdisk -l device will list all partitions of a device. If you want to verify, if you want to view the partitions available for that device, you can do sudo fdisk -l and then the device. Fdisk device will edit the partition table of a device you want to edit, you want to delete, you want to create new partitions. You can use this command. This command, part_probe device, will update the system of the changes. Let's say you created a new partition from an old hard drive. After that, you need to issue this command so that the system will be updated that there are new partitions available on the hard drive. This command will format the partition. Let's say you created a new partition. It's not enough that you created a new partition and then it will run immediately. Before you use it, before you place files, your documents in that new partition, you need to format that partition in order for it to be used. So with this command, sudo mkfs.ext4, and then the device will format that new partition. And then df, the df command, will list all mounted partitions. So let's say if you have a second hard drive of 10 gig and you want to add that 10 gig hard drive or SSD into your Linux system uh, virtually, we can add a virtual hard drive into your Linux system, into settings, storage, and then click on this icon here, add attachment, and then hard disk. Click on add. I mean, click on create, and let's say your example is only 10 gig. Click on finish. So once there will be a secondary disk on your controller SATA, then you're fine. So now let's boot up our system. So our Linux system has booted up. Let me just log in. And then to verify if the second hard drive is already installed, you do this sudo fdisk -l, and then you should have this disk/dev sdb. Your first hard drive is SDA. Your second hard drive, which we added a while ago, is SDB, in which it has only 10 gigabits. Okay, so now let's partition your newly added hard drive by doing this command fdisk/sdb. Let's press M for help. Okay, and then our purpose is what are the partitions available on the secondary hard drive. Let's do P. There's no partitions yet, so let's press help again. We will create a new partition. It says N. Okay, we will press N. Then we will choose the primary partition. Okay, we'll only use primary partitions for this drive as of the moment. Partition number, let's just press enter. And then in here we will type in, let's say we will partition with 5 gig each. So okay, this is equivalent to 5 gigabit from the 10 gigabit secondary hard drive. Oops, press enter, and then plus 5G. So if we print the new partition, we should see a new partition which is called SDB1 right now, and this size is 5G or 5 gig. Now let's add the next partition. which is another 5 gig, because it is the secondary hard drive is only 10 gig. Enter, enter, and then let's say press enter, because we will use up the remaining size for the second partition. So basically we have created a new partition with the size 5G. If we print partitions, we have already two partitions from the secondary hard drive, SDB1 and SDB2. Okay, how to save this? Let's ask for help. And it says here, save and exit by pressing right W, which is write the table to the disk and then exit. So we will press W, and that has been saved to the partition table, has been saved to the disk. Now let's issue this command so that the Linux system will know that there are new partitions for the secondary hard drive. If we will issue df, you can see that there is still no SDB partitions in the system. So what we will do is format the partitions. Before we can use the new partitions, we need to format it so that the user can place files, can place their documents on the new partition. So how to do that? Let's just type in sudo mkfs ext4 /dev sdb1. So with this command, we are formatting the first partition of the secondary hard drive. We were formatting the second hard drive first partition into the ext4 file system. This is the default file system for Linux, Ubuntu Linux, and we're done. Now for the secondary partition of the secondary hard drive. Okay, that's done. Press df, still not available. If we want to verify the file size of our partition, you can issue this command sudo fdisk -s /dev sdb. First partition is around 5 gig. The second partition is also around 5 gig. Okay. So in order for you to use the partitions that you've just created, we need to have mounting points. Okay, these mounting points are just directories in Linux, in which these are the directories that you need to access so that you can place files in the partition. So how to do it? Let's go to this directory, cdmnt, and we will create the directories. So let's say disk 2 1. So we created two directories for the first partition, and this directory is for the second partition. If we do ls-l on the directory, we have created two directories, disk 2-1, disk 2-2. Let's change the permissions so that all users can access the partitions. Sudo ch 1 and this 2-2. Okay, so all users can now access and use these mounting points for the new partitions. Now we will mount the partition to the folders that we have just created. We will mount the partitions that we've just created to this mounting folders in /mnt. So the command is sudo mount /dev sdb1, which is the second hard drive first partition. We will mount it to this mounting directory 2-1, and then we will also mount the second partition from the second hard drive into this directory. So if we will now press df, we have these two partitions already present and usable in our Linux system. So let's say I want to create file on the disk 2, disk 2-1. So we go cd disk 2-1, and then let's say 2-1.txt. This is the first partition. This is the of the second hard drive. So there is now a file called disk 2-1. If we will go to this 2-2, we create another file 2-2.txt. This is the second partition of the second hard drive. We will save this, and we see that there is also a 2-2.txt file. Okay, we have the content, we have the file size, and the two new partitions are loaded into the Linux system. So if you have any questions, feel free to message me or approach me during our lab hours.